Hey everyone! In this video we're going to talk about observational studies. So in the previous videos I talked about randomized controlled trials as kind of the gold standard for causal inference. And although these experiments and randomized controlled trials can provide an internally valid estimate of causal effects, in many cases social scientists are not really able to randomize or randomly assign a treatment similar to the examples that we saw in the previous video. This could be for either ethical or just logistical reasons. So in this video, we're going to consider observational studies in which researchers were not able or are not able to control and conduct the intervention themselves. Okay, instead, in observational studies, researchers simply observe naturally occurring events and collect and analyze the data that is available. Okay, so observational studies, as I said, in many contexts, we cannot randomize a treatment either for ethical or logistical reasons. So one example you could think of that is straightforward is, if we want to examine the effect of smoking on lung cancer. Because we wouldn't want to randomly assign people to, smoking a pack of cigarettes a day. So in cases like these, instead of assigning an intervention, we have to leverage a naturally assigned treatment. Okay, and whenever we talk about observational studies and comparing them to experiments and randomized controlled trials, we have to kind of think about a trade-off between external validity and internal validity. So what we mean by external validity is the question of to what extent we can the conclusions or whatever results we get in our study can be generalized beyond a particular study, and internal validity, which usually kind of focuses on whether the assumptions to identify causal effects are actually satisfied in the study, right? And so obviously, observational studies have or are generally weaker when it comes to their internal validity because we don't have direct control over the treatment assignment, and so causal inference is much more difficult, right? This is because pretreatment variables or other potential confounding variables may differ between the treated and control groups, or between observations that have received the treatment and those who didn't. And ultimately, this can lead to confounding bias, and I will talk in a second about what exactly we mean by confounding bias. There could also be selection bias in the sense that certain observations might self-select into receiving a given treatment, right? So, for example, thinking about smoking, of course, there are certain determinants that affect whether someone starts smoking or not. And so these might ultimately also affect outcomes like health and life expectancy and things like that. So so in these cases we need some additional measures in order to make sure that we kind of account for these potential confounding factors. So observational studies obviously have a weaker internal validity, but are stronger with regard to the external validity. Okay, so usually with observational studies, we can have larger, for example, in representative surveys, we can have representative samples, and so it's easier to generalize beyond the particular study to a larger population. In smaller lab experiments, for example, we don't have a representative sample, and so it's harder to make these extrapolations beyond the sample of the study, right? So experiments are usually weaker when it comes to their external validity, but we have more control over the assignment of the treatment, so they're stronger with regard to the internal validity. So I mentioned confounding bias, and I want to briefly talk about what exactly we mean by confounding bias. In general, confounders are pre-treatment variables, so that are associated with both the treatment and the outcome variables, right? So it's some additional factor that affects both our case here, we have our treatment, and we have y. So for example, in this context of smoking and the likelihood of developing lung cancer, okay, we have the treatment of having a smoking habit or not, and an outcome of experiencing or developing lung cancer over the course of one's life. And there are of course a lot of potential confounding factors that affect both whether or not someone starts smoking and whether or not someone develops lung cancer. Or suppose, for example, the outcome is not lung cancer itself, but is just general life expectancy as one measure. Okay, so in this case, what is a potential confounding factor? Well, we could think of, for example, sociodemographic background, right? So, or income and the like, right? So people from lower economic or with lower economic status might be more likely to start smoking, but we also know that lower economic status affects health outcomes. So people with from a poorer background have potentially lower life expectancy. So this is a potential confounding factor. So unconfoundedness means that the treatment, so that's the absence of confounders. That means the treatment and control groups are comparable with respect to everything other than the treatment. And as soon as we have confounding bias, as soon as we have these confounders that affect both the treatment assignment and the outcome, then these groups are not comparable by themselves anymore, and we have potential bias. When we talk about selection bias, what we mean is it's kind of a specific form of confounding bias due to self-selection into the treatment group, and that's a very common way of introducing confounding bias, which is if there are certain factors that determine whether you self-select into the treatment, right? So in the example that I mentioned earlier, the self-selection would be deciding to start smoking or not, right? That is determined by or affected, influenced by other characteristics. And this is one of the big reasons, this potential for confounding factors is one of the main reasons why we're saying that association, just a bivariate relationship, or even controlling for other factors is not necessarily causation, because there could always be potential unobserved confounding factors, okay? So in the context of observational studies, how can we reduce confounding bias? In general, confounding bias in the context of observational studies can be reduced through statistical control. And for us now, we'll talk, throughout the semester and also the next semester, we'll talk about different ways of kind of achieving the statistical control. But in the context for now, the way we think about this is by using the method of subclassification or subsetting, right? So by comparing treated and control units which have an identical value for a potential confounding variable, right? So what does this mean formally in our context of potential outcomes and average treatment effects? We're basically introducing an additional covariate, in our case x, and we're saying that now we're holding the potential confounding variable constant, and we're only looking at the treatment effect holding that potential confounding variable constant, right? So we're looking at potential outcomes that are now conditional on x. So here we have yi0 conditional on x, so kind of holding x constant, and yi1 conditional on x. And we're basically just saying that once we condition on our confounding variable, then the treatment assignment has to be independent of the potential outcomes, right? So previously, the previous result that I showed you, where we derived the average treatment effect, we said that the potential outcomes themselves have to be independent, statistically independent of the treatment assignment. And now we're saying, we're kind of relaxing this assumption a little bit and saying only after conditioning, only after holding constant this confounding variable, the potential outcomes have to be independent of the treatment assignment. Okay, if we do that, that implies that again, this kind of the same logic, that the expectation of our potential outcome in the treatment group conditional on X is the same across treatment or assigned treatment and assigned control. Okay, so that's equal to the potential outcome basically marginalized over treatment on control. Okay, so that means after conditional on X, there are no systematic differences in the potential outcomes in the treatment and in the control group. So the same logic, but just adding this caveat of now we have to kind of condition on X. Okay. So the idea here is, to kind of, in plain simple terms, to find similar units as a baseline of comparison for treated units. And that's kind of the underlying idea behind matching, which we'll talk about later as well. So in the context of the examples in the book, for example, when we talked about the minimum wage increase and the effect of the minimum wage increase on the unemployment rate, we can say that, for example, in the context of trying to estimate the effect of New Jersey increasing the minimum wage, the idea would be to find a state that is similar to New Jersey on all potential confounding factors, but didn't increase the minimum wage. Okay, and that would be then conditioning on these potential confounding factors. Okay. The problem, of course, is that we cannot match on everything, right? So in the context of this minimum wage study, there are only 50 states that we could, at least in if we studied this in the US, where we could potentially look at comparisons. And there's no way we can, if we have a large set of potential confounding factors with a complex problem like, unemployment, that is likely to be the case, we are not going to be able to match on all of these potential confounding factors, right? So what we're left with is oftentimes that there's still unobserved confounders. So there's still unobserved variables that are associated with the treatment and the outcome that still lead to selection bias and that still kind of jeopardize our potential causal inference in the context of observational studies. Okay. But the problem is, of course, so we will never get to this perfect, gold standard of a randomized controlled trial, but we can still try to minimize this confounding bias, right? And so the question here becomes, how can we find the best possible comparison group that gets us closest to this idea of a balanced treatment and control group, okay? And I'm going to look at this example of minimum wage and unemployment in a little bit more detail here. And just to reiterate, the research question here is, how does an increase in the minimum wage affect unemployment? And of course, this is a really important question for social scientists, economists, and political scientists alike, because there's a lot of debate around the federal minimum wage, and there are economists who argue that increasing the minimum wage too much could ultimately have negative repercussions in the sense that it could increase unemployment. Of course, in this context, it's hard to randomize the minimum wage increase. It's hard to run a true randomized controlled trial. But so we have to rely on observational studies. Okay, so in the study that is discussed in the chapter, we have two social scientists who tested this using fast food chains in New Jersey and Pennsylvania. And specifically, in 1992, New Jersey increased its minimum wage from $4.25 to $5.05. In the neighboring Pennsylvania, it stayed at the lower level of $4.25. Okay, so the idea is here we use this case to observe unemployment in both states before and after the increase, and then try to provide an estimate of the causal effect of this increase in the minimum wage. Okay. And I guess one thing I should say in the context of choosing or focusing on minimum not only focusing on two states that neighbor each other and that have the same baseline of the minimum wage prior to the change in New Jersey, it is an important detail to focus on fast food chains specifically, because fast food chains here in New Jersey and Pennsylvania are similar. They usually have similar or probably the same prices across both states. They have similar wages and similar products, so they're very comparable across states. Okay, so they allow they're a perfect case to kind of make this comparison of just what is the effect of the change in the minimum wage. Okay. So the data that we're going to look at, and that is also going to be on RStudio Cloud, so please open the data set and go through it as you watch this video, has a couple of pieces of information. The data set here, and I included also the code to directly load the data set, minwage.csv, and we can again look at the structure and the first couple of observations of that data frame using the structure command and the head command, and we see that we have 358 observations. These are different fast food chains in Pennsylvania and New Jersey, and we have information on the wage before the law was changed, or the minimum wage was changed in New Jersey. We have the wage after the change. And then we have information about unemployment before and after in terms of both full employment and part-time employed. So these are here, number of part-time employees and number of full-time employees. Okay. So if we want to kind of now examine this question, there are a couple of different strategies. But before I get to these strategies, I want to first talk about whether the minimum wage itself affected the wages in New Jersey, right? So this is kind of the first thing we want to check. The law changed, but do we actually see that this law changed wages in New Jersey? So in order to do this, we can subset the data by state. So we look at the minimum wage data in New Jersey and in Pennsylvania. We use the subset command here, with the first argument being the original data frame that we worked with, and we're subsetting it, one for location not being equal to Pennsylvania and one for location being equal to Pennsylvania. And then next we compute the proportion of restaurants whose wage is less than $5, right? Because presumably we could also, imagine that in New Jersey, prior to the minimum wage increase, maybe the wages were already so high that the law change didn't actually have any effect, right? So in order to make sure that this is not the case, we look at both in New Jersey and in Pennsylvania the proportion of cases that paid less than $5.05 before and after the minimum wage increase. And we see for New Jersey that before the change, 91% of the restaurants paid less than $5.05. And then, of course, after the change, since they all comply, or at least almost all comply with the legal requirements, the proportion of stores that a proportion of restaurants whose wage was less than $5.05 is almost zero. Okay, so that's the first part. We see that this law change actually had an effect in New Jersey. Now the second part, what happened in Pennsylvania, and we see that prior to the law change, we see a similar rate of wages being below $5.05, and that stays constant. So they were clearly not affected by this regulation. The next thing we want to think about is whether New Jersey and Pennsylvania restaurants are actually comparable, right? And so in order to kind of assess whether the wages before the increase of the minimum wage, whether both units of analysis are ultimately comparable, one way to look at that would be to look at the actual average wages before the increase of the minimum wage, okay? And we see here, if we compare the averages in New Jersey and Pennsylvania, just by using the mean command, we see that they're quite similar. In Pennsylvania, they were slightly higher with $4.6 an hour, and in New Jersey, slightly lower, but on a comparable level. Another factor to compare prior to the law change is to look at the proportion of full-time employment, both in New Jersey and in Pennsylvania. And we can do this here by dividing full-time employment by so the number of sorry, let me go back for a second. So this is actually the number of full-time employees before the minimum wage increase. So this is the number of full-time employees divided by the total number of employees. So we have here the full-time employees plus part-time employees, right? So we want to look at how many people are full-time employed as a proportion of the total employment in New Jersey and compare that to Pennsylvania, right? And so we do the same thing here, computing this proportion for New Jersey and for Pennsylvania, and we see that about 30% of employees were employed full-time, both in New Jersey and in Pennsylvania. So these are all different potential confounding factors, and we see, at least for these cases in New Jersey and in Pennsylvania, it appears that the fast food restaurants in New Jersey and Pennsylvania prior to this law change were relatively similar, so comparable across a couple of different measures. And so we can proceed to kind of examine how the change in the minimum wage ultimately affected unemployment. Okay. So how can we then evaluate this potential, the effect of this potential of this intervention? And there are three different strategies that I will focus on. The first one is a basic cross-section comparison. So the basic cross-section comparison means we compare the proportion of full-time employees in New Jersey and Pennsylvania after the increase of the minimum wage in Pennsylvania, right? And as I go through this example, I want you to think about what are the kind of, if we're trying to estimate we're interested in estimating the causal effect of this minimum wage increase, and I want you to think about what the potential confounding factors are. What are potential factors that we're not taking into account that affect basically that are systematically different between New Jersey and Pennsylvania, and that also affect the unemployment rate, okay? And so in order to compare the proportion of full-time employees in New Jersey and Pennsylvania after the increase, we again compare this proportion in both states, and this is the similar computation that we did before, just for the period after the minimum wage was increased. And then we estimate the sample average treatment effect by subtracting the average full-time employee, or the average proportion of full-time employees in New Jersey minus the average, the proportion of full-time employees in Pennsylvania. All right, and we see that here, at least, the full-time proportion, the proportion of full-time employees in New Jersey is 4 percentage points higher than in Pennsylvania. So that seems to suggest, which, this result in of itself seems to suggest that the increase in the minimum wage in New Jersey actually increased the proportion of full-time employees. So this is kind of against the economists' concern that increasing the minimum wage increases unemployment, okay? But of course, there are potential problems, because here we're just looking at the cross-section comparison between New Jersey and Pennsylvania after the law was changed. And so ultimately what we're doing is we're assuming that the treatment and control groups, so restaurants in Pennsylvania and New Jersey, we're assuming that they're identical on average in terms of all potential confounders. And in this case, there might be other potential factors that might result in systematically different unemployment rates in Pennsylvania and in New Jersey. Okay. So another strategy to kind of examine the same underlying causal effect that we're interested in is to look at a before and after comparison. Okay. And here we're comparing the proportion of full-time employees in New Jersey before and after the increase. Okay, so this this strategy kind of in this case we had the potential confounders that jeopardize our causal inference. Are focused on state-specific factors, right? There might be some unobserved differences between both states that affect the unemployment rate after the law was changed. We can basically reduce that risk by focusing on the state itself, so only focusing on the change in New Jersey before and after the law was changed. That helps us address these state-specific confounders that we had in the cross-section comparison, but now all of a sudden we have potential issues with time-varying confounders. So maybe something changed over time in New Jersey that we're not holding constant now, right? But just to go through the logic, in order to make this comparison, we would look at the average difference in the average difference in the full-time employment before New Jersey passed this law and after New Jersey passed this law. And again, we see an increase. So after New Jersey increased the minimum wage, we see a higher number of full-time employees. But of course, there are other factors. You know, the economic situation also probably changed. There was economic growth and things like that. So these potential time-varying confounders are still potential threats for our causal inference here. So this brings us to our third strategy, which is differences in differences, or difference in differences, right? So the key idea here is to use Pennsylvania before and after, the difference between, or the change in Pennsylvania between before and after the law was changed, and use that as a baseline for comparison to compare what happened in New Jersey before and after the law was changed, okay? So that helps us to address within state confounding and also address changes over time, okay? So here we estimate the sample average treatment effect for the treated. So this is a kind of an important difference rather than just looking at the average treatment effect across all units. The difference in difference estimator only allows us to make an argument or kind of estimate the average treatment effect for the treated. So for the average treatment effect in the group that actually received the treatment. So what does this exactly mean? That means kind of in our example, we're estimating the effect on the effect of a minimum wage increase on unemployment in New Jersey. That may or may not be equal to the effect of the minimum wage increase in Pennsylvania, but we can't really be sure, right? So we have an estimate of the effect in New Jersey, but we don't necessarily, we can't really, without additional assumptions, we can't really be sure that this is also equal to the, obviously, to the effect of a minimum wage increase in the control group in Pennsylvania. And so that's what we mean by the average treatment effect for the treated. It's the average effect that we estimate for the treated unit itself, okay? So in order to do this, we want to compare the difference in difference between New Jersey and Pennsylvania. And previously, here on the previous slide, I already kind of computed the overtime change in New Jersey. And so here we're computing the same difference in employment in Pennsylvania, and then we're looking at the difference between New Jersey and Pennsylvania, and we see again an increase. So we see a positive effect of the minimum wage increase in New Jersey compared to Pennsylvania. So an important point, the difference in difference estimator yields an invalid estimate for causal effect if the time trend for the counterfactual outcome for the treatment group is not parallel to the observed time trend for the control group. So this is the parallel trends assumption, and that's a really crucial assumption as soon as you're using difference in difference designs. I guess the best way to kind of think about this is to kind of think about this graphically, right? And this will, I'm going to use this graphic also to kind of summarize the three different identification strategies that we talked about, right? So what does the parallel trend assumption mean? Ultimately, what we see here is we see the control group, we see the average proportion of full-time employment. We look at the control group in Pennsylvania, and we see that the control group in Pennsylvania went from 0.31 to 0.29 or something like that. We see that in the treatment group in New Jersey, before the minimum wage increase, it increased from the proportion of full-time employment increased from 0.3 to 0.33 or something like that, right? The parallel trends assumption means that we assume that in a counterfactual world where New Jersey hadn't implemented the minimum wage increase, that the trajectory of the unemployment or the full-time employment rate in New Jersey would have been parallel to the trajectory of the employment rate in Pennsylvania. So the counterfactual New Jersey would have been parallel, and if New Jersey hadn't increased the proportion, it hadn't increased the minimum wage, it would have a lower minimum, it would have a lower proportion of full-time employment and would be down here, right? So the average causal effect, the difference in difference estimate is then the difference between what we observe in the treatment group for New Jersey and this counterfactual New Jersey if New Jersey had followed the same trend as the control group. And that is then this difference in difference estimator, okay? So to summarize our three different identification strategies, the first one that we talked about was a cross-section comparison. So we're comparing treated units with control units after the treatment. The treatment happens, and then we look at some units that were treated, some that weren't, and we look at the difference between the two. Of course, the assumption here is that the treated and control units are comparable across, all other unobserved characteristics. And they introduce the possibility of unit-specific confounding. So factors that are different between New Jersey and Pennsylvania, for example. The second strategy that we looked at was the before and after comparison. So we're comparing the same units. Or to go back to the cross-section comparison, that would be the comparison between New Jersey after the change and Pennsylvania after the change. And the assumption is that outside of the difference in the change in the change in the minimum rate, New Jersey and Pennsylvania should be equal on average, okay? For the before and after comparison, we look at the change over time only for the treated unit, and we're assuming that there's no time varying confounding. So here we're looking at the difference between New Jersey after increasing the minimum wage and New Jersey before increasing the minimum wage, and use that difference as our treatment or estimate of the treatment effect. And that of course assumes that there are no other time varying confounders that changed in between those two time points that also affected the outcome. And then we have the difference in difference estimator, which assumes parallel trends. So it assumes that the counterfactual New Jersey, if they hadn't increased the minimum wage, would have been on a similar trajectory as Pennsylvania. And that accounts for both unit-specific and time-varying confounding. And it estimates the sample average treatment effect for the treated. So only kind of for New Jersey, it estimates the average treatment effect. So in general, one important thing to say is that neither approach is the best in general. The important thing that I want you to recognize is that these different approaches, they all require different assumptions. So they have strengths in certain areas and or certain contexts, but might have weaknesses in other contexts, right? These assumptions, like the parallel time trend assumption, they can be very plausible in a given context, but it can also be easily violated in another context, right? It depends on the context. It depends on the underlying data generating process and the underlying, the underlying mechanisms, right? So there's no one best approach for every case. It always depends on how plausible the underlying assumptions are. All right, this is all for observational studies. In the next video, I'm going to talk briefly about descriptive statistics for a single variable.